regarding to some internet problems, I switched my presentation from advanced patterns and live coding to another advanced topic, higher order observables with no live coding. Sorry for this, but StackBlitz is very shaky at the moment and don't want to risk any further problems. Okay, let's start. This talk is about the ease of using higher order observables in rxjs. What is the agenda? What's on the menu? First, I will clarify some terminology. I'll give you an overview of all the operators. I will categorize them. I will use some approach that is called the algebraic approach. And then I go straight into operators. So this is an overview of all the higher order observables or higher order operators that we have in Rx. It's 38 operators, and in this talk I will cover more than half of all these operators. First, let me quickly introduce myself. I was doing pair programming with my computer for a long time, and then I was pretty pissed and I wanted to stop coding and try something else, and then luckily I met a person that said, well, maybe you don't switch completely, maybe you just adopt what you do, and since then I do trainings and consultings, and I'm way more happy than before. So if you want to book some consulting, just contact me. Okay, let's start with the terminology of operators. There are observables, and there is something that is called order of observables. Let me first introduce you first order observables. What are first order observables? Well, first order observables are observables that emit single values. As you can see here, the values emitted are single values. What is a second order observable? A second order observable is an observable that emits other observables, which in turn emits single values. And then there is a third order observable, and third order observables emit observables, which in turn emit observables, which in turn emit single values. And to explain what fourth order observables are, I will use the whole next slide. No. So when we speak about the order of observables, we just speak about first and higher order observables, no matter how high the order is. And then there are operators. There are first order operators, and first order operators transform single values to other single values. There are second order operators. They either take an observable or return an observable or do both. And of course then there are third order observables. Third order observables, as you can see, take an observable and emit a higher order observable or the other way around. And same as with observables, operators are either first order operators or higher order operators, just that we get the terminology of the order of observables. Next thing are operators, operator functions. So there are creation functions or static functions. These functions return an observable out of nothing. And then there are operator functions. They always take an observable and return another observable. So this is the other kind of category or terminology that I want to clarify here. Very good. So this was the terminology. Now let me categorize them. So the vertical categorization is either first or higher order operators, and then I will have static functions or operation functions. Good. Next theory that I will use to explain these operators is an approach that I call the algebraic approach. Why do I call this algebraic approach? Well, if you ask Wikipedia and you ask for algebra, it means more or less directly translated reunion of broken parts. So what do I mean with reunion of broken parts? You can break these operators, all the operators, in their single words, and what I will do is I will try to explain operators by explaining all their parts, and then later on we will understand operators by looking at their parts. So switch map 2 consists of a switch, out of map, and out of 2. And this is my algebraic approach, which I will use to explain a lot of complex operators here. Okay, let's start. Let's start with this subset that I will explain. I have not enough time to explain all of these operators, but at least the most important ones. First, let me talk about the primitive part of those operators. Let me talk about map and 2. Map is already visible in 8 operators. So if you understand map, we understand 50% of these 8 operators. And map is a really simple one. You have an input stream, and then you map the incoming values from A to B, so it is a transformation. If I speak about transformation, I always think about bringing something from A to B. So trans means bring something from A to B, and formation is obviously related to the form of the value. Well, we can use this map operator not only to transform to other single values, we can also use them to transform this value to something completely different. We can take these single values and transform them to, for example, other observables. And they deliver their single values. So this was map and some use cases for map. When to use map, as I said, always when you want to bring something from A to B, so the shape of a value from A to B. Let's talk about 2. What does this 2 mean, the part 2? Well, 2 is pretty simple. You have incoming values, and no matter what you do, you basically always transform them to the same value. So no matter what you receive, you always transform them to the value 42. You use 2 when you don't care about the incoming value, because you know you will always map it to a certain outcome value or output value. And those are the basic operators, the basic parts. Another basic part is scan. What scan is doing, it is very similar to the array first class function reduce. It maintains an internal state, it stores this state, and over time I can change this value. So I will start with my internal value for 0 here, and then for every number that arrives, I want to calculate the sum of these numbers over time. So I start with 0, then 4 arrives, and I will add 1 to 0, then the next number arrives, and I again add this value, and I again add the next value, and in the end I have the sum of all those values. So this is scan. And there is another operator that is called reduce, which is pretty much the same. The only difference between scan and reduce is that nothing will happen, same logic inside, but the output values will not appear. The output values will not appear as long as this stream is ongoing. And only if this observable completes, I will receive the last calculated value here. So this was scan and reduce. Also one of the simpler parts. And you can use scan or reduce whenever you want to maintain internal state or do some calculations. Okay, those were the simple parts. Now we can go on and start with more complex problems or more complex operators. I want to start with a group that I called flattening and merging operators. I will talk about the 4 parts: concat, switch, merge, and exhaust. First of all, here we see an overview, and all those operators have something in common. All of those operators sort value related to time. Here you can see the output of all those different, so the order of what is the result of all those operations. And I will start with one of those operators, one of the simpler ones that is called merge. So how can we think about merge? Let me first show where merge is included. Merge is included in 5 different operators. And we will start with the static function of merge. Merge takes 2 input observables and merge those observables together. What does it mean? Well, let's say our first input stream emits a value, and this value is projected into our output stream. And then the second input observable again emits a value, and this value is again projected into our output observable just in time. So we will not change anything in the order of time. No matter how many values all those observables emit, we will merge them together in this single output stream. The exact same operator, just with the map on the end, does something similar but a little bit different. So merge map obviously have this map part inside. And what map is doing is transforms something in something else. In our case, map takes a single value A and transforms this single value into another observable. And this observable starts to emit values. And then we have a new single value that enters the input stream, and again we take this value and again turn it into an observable. And this observable also starts to emit values. And in the end, we merge all those emitted values together in one single output stream. Very useful if you want to, for example, merge different WebSockets together. Okay, when to use merge? Merge has several use cases. One very cool use case is you can use merge to maintain only a single subscription. So you put all your side effects not in a subscription block but in a tab operator, and then you use merge to subscribe to all of those operators in one place and maintain only one subscription. Merge is also very interesting if you don't care about the order of the emitted events, because they are just in the same order as they appear. And then merge map, to be more specific, has some very cool parameter that is called concurrency. And with this parameter you can decide how many parallel observables are started inside of this operator. Try to guess what happens if you set the concurrency to 1. Before I answer this, I want to talk about concat. Maybe this is a little hint. Okay, so let's talk about concat. Concat has a lot of variations. We can see concat has 7 variations, and they are very, very similar. Let's start with the very basic one. Let's start with the concat static function. This function takes an array of observables, and when we subscribe to this observable, to this operator, we start with the first observable, and this observable emits values. And only if this observable completes, we take the second one of this array, and only after the completion we subscribe to the second one, and then we emit all the values of the second observable. So concat really sequentially processes all those asynchronous operations. It is very good to maintain a sequential order. As we know concat now, we can talk about another operator that is called start with. And start with doesn't sound like a concatenation operator, but in fact start with is an operator that internally uses concat before the stream that is initially used. So start with concats some observable or some value to your original stream. Same with another operator that is called endWith, and endWith is doing the same stuff, it just concatenates the observable at the end of your stream. So if we understand concat, we also understand start and end with. And then we have this concat map. We already know what map does, right? We always use map to transform something from A to B. In this case, I receive a single value and I map it to another observable. This observable emits its values. And then I have the second single value coming in and I try to do something, but nothing happens. Nothing happens as long as our first internal observable is still ongoing. And only if this observable completes, I take the second value that arrived and turn it into an observable and subscribe to it, and then, only then after the completion, I receive all the other internal values. There is another operator called concat map2, and as we know what map and 2 is doing, we... Was this a sign for me? A time sign, 8 minutes. Okay. Okay. So concat map maps it always to the same value. No matter what we receive, we always map to this observable here. We use concat when we want to process sequentially all those asynchronous processes. And then there is switch. What is switch doing? Let me first show that there are 3 operators with switch: switch map 2, and switch all. And very similar to our concat, we receive a single value, we turn this single value into a stream, and this stream starts to emit values. And when the second single value arrives, something very interesting happens. I again turn this single value into a stream, but at the same time I unsubscribe from the previous one. So the new stream will emit the values, and no matter what the previous stream would do, I ignore it and I only focus on the most recent initialized observable. So this is switch. Switch map, very similar to switch map, is switch map 2, just the output observable is always the same. Switch is very cool if you try to manage several fetches from some backends and you want to avoid race conditions, so you want to always focus on the most recent HTTP request, for example. Then there is another operator, also one of those flattening operators, that is called exhaust. Exhaust is in this overview here 2 times. There is exhaust map and exhaust all, but there is no all in the operator name. In fact, it should be named all because it is very similar to all the other all operators. Exhaust map is not very well known, but super powerful. Exhaust takes a single value and initializes this internal stream. And this internal stream starts to emit its values, and then we have more other single values coming from outside, but we completely ignore those incoming values as long as the internal currently running stream completes, and only then a new incoming value can initialize another observable. Exhaust is very cool if you, for example, have a refresh button on your page, and I guess you know these not really patient people, your internet connection is slow, and then they take the refresh button and hit it, I don't know, 10 or 20 times in a row like me. This is the perfect operator for those people, because they can hit this refresh button as often as they want. They will not really initialize other requests. Perfect, let's switch to the second chapter, which is called combination operators. And here I again have 4 different operators, or 3. And all those combination operators grouping values based on some trigger event. Let me give you a quick overview. We have combine with latest and zip, and as you can see, they always emit group of values, but the trigger is different. Let me first explain zip, and then you maybe will realize what I mean with trigger. So zip is a creation operator. It takes two different observables, and let's start with the first observable. This observable emits a single value, and as you can see, nothing happens. Nothing happens until the second value arrives, and this second value triggers the first emission, which is a pair of the first and the second stream, both of the first values. Then the second operator emits a value, and again nothing happens because zip always waits until both streams emit a new item. And only if the second stream emits the new item, I will receive this new group. So I guess Lodash has a very similar operation, but just a synchronous operation and not asynchronous. So zip. Let's take a look when we can use zip. We can detect changes of value pairs. To save you some time, I skip more of the examples and I directly go to the combine all operation, or to the combine operations in general. The combine latest operator is also a creation method which takes two observables, but it is a little bit different than zip. So when zip was waiting for every emission from every other observable, combine latest ignores just the first emission, and then it will emit a value whenever any of those internal observables emits a value. So here, in the same pattern, we receive a pair of values whenever any of those internal observables emits a value. There are several use cases where you can use combine latest. One of my favorite use cases is if I have two different sources of, I don't know, tables, and I want to do something like an inner join in the front end. I always use combine latest because no matter which of my tables changes, I always can recalculate the new table out of it. Fork join is exactly the same as combine latest. Not a lot of people know this, but fork join has a very, very tiny difference. I emit values and I would see those groups here, but nothing happens. Nothing happens as long as both of my observables complete, and only then, and this completion of all internal observables is the trigger, only then I will see the emission of this group here. So fork join focuses on the last emitted group. This works very well for HTTP requests. Combine latest would work very well for WebSockets. As I said, fork join is, I guess, best for HTTP requests because it will not work for WebSockets. And the last combination operator that I want to explain is with latest from. With latest from is a little bit different. Let me explain what the difference is. So we have this I2 stream here, which is emitting values. And then I have my input stream. And my input stream starts to emit values and nothing happens. Also here, if my internal stream emits a value, nothing happens. Nothing happens as long as a second value arrives here, and then at this point I have a last value from the internal stream, and then I will forward this last value. So the trigger here is our input observable, and whenever my input observable triggers, I try to get the last value from the internal observable. Some other variations here, but as you will realize, they work pretty much the same. I always try to get the last emitted value from my internal observable whenever my input observable emits a value. when to use with latest from whenever I have a primary stream that should trigger receiving the emission of a secondary stream. And then there is a set of all operators. I will skip pretty much all of them. I will just give you one example of an all operator so that you can get a better idea of all those other all operators. So all operators are operators for higher order observables. And a higher order observable is an observable that emits observables internally, which looks like this, and there are several of them. I will only focus on one of those observables. Just to quickly recap, we have this map operator, and this map operator can turn a single value into another higher order observable here. So this is basically the pattern that you should have in mind when you think about all operators. And I want to talk about the merge all operator, because it is, I guess, one of the easier ones to think about. So this is my input stream for merge all, a higher order observable that carries two observables inside, and those two observables emit yellow and green values. If I pass this input to my merge all operator, I see that I receive the first observable, and then I subscribe to this observable, and all emissions of those observables are projected into my output stream. Also, the second value, which is another observable, is internally subscribed to, and all the other submissions are also merged together in one. Pretty much as merge would do, but the difference here is that our input stream is a higher order observable and not an array of observables. This is really the only difference. Let me quickly skip the other one and sum everything up. So we took a look at two different groups, to be more specific, three, but the groups were flattening and merging operators, like map, switch, concat, and exhaust. And those operators helped us to sort values based on some time. And then we had combination operators, and combination operators were here to emit value groups based on some trigger, and the trigger was different for all of those operators. If you're interested about these diagrams, I work on something that is called Marble Design System. It is a design system for all those marble diagrams. If you want to help me with this, there is still a lot of work to do. You can picture those two links. There is a GitHub issue open, and there is the slides publicly available. You can create comments there, and I will definitely include all the comments in my work. And I guess it's time to finish. Thanks a lot for your time. Sorry to quickly switch the presentation, but these technical problems with Amazon were not so nice, so I tried to make it safe and switch the presentation to another topic. I hope it was still interesting for you.
It was indeed, Michael. It was indeed.
Thanks.
Thank you.